In example 3.7, we're looking at flipping two fair coins, and we want to find the probability of these events. So first what we're going to do is we're going to get the sample space. So here we have two fair coins. So I have coin 1 and coin 2. They both have a heads and tails. So the two possibilities for coin 1 is a heads and a tail. The two possibilities for coin 2 is heads and tails. So let's make our sample space. So I'm going to call it S. And my first possibility is heads and a heads. My second possibility is the first coin is heads and the second coin is tails. The next possibility is that the first coin is tails and the second coin is heads. And the next possibility is that the first coin is tails and the second coin is also tails. So here's my sample space. This is a total of 4 possible outcomes. Okay? So now let's look at letter A. A says F is the event of getting at most one tail, 0 or 1 tail. So let's see, 0 or 1 tail. So I have one tail here, one tail here, no tail here. So that's 3 options. And if I want to list those 3 options, I can. This last one's not included because it says at most 1 tail, and this has 2 tails, so we're not including that one on this problem. So the probability of F is going to be 3 out of the total, which is 4. B. Let's use a different color. For B, we're going to let G equal the event of getting two faces that are the same. So we're looking for heads, heads, and tails, tails. In our list, there are 2. Heads, heads, tails, tails. So G is 2. So the probability of G happening is 2 out of the total 4. And if we reduce that, we get 1/2. Letter C. Letter C says to let H be the event of getting a head on the first flip, followed by a head or a tail on the second flip. So in the first flip, we have a head. First flip, we have heads. These two have tails in the first flip, so we're not looking at that. Second flip is head or a tail, so both of these are included. So that means there are 2 possibilities for this event. So the probability of H happening is 2 out of 4. Letter D. Letter D is asking us for are F and G mutually exclusive? Now, mutually exclusive means that they don't have stuff in common. So I'm looking at F. F is the blue one, right? Our blue case here. And I kind of have the dots here where the blue case is. And then G was the red case. So you can see here I have a blue and a red. So they share heads and heads. So because they share this possible outcome, this would be that no, they are not mutually exclusive. And the reason why they're not mutually exclusive is they both contain the outcome of the possibility of heads, comma, heads. Heads on the first flip and heads on the second flip. So that's the reason they are not mutually exclusive. Letter E says, let J be the event of getting all tails. Are J and H mutually exclusive? So let's find the probability for J first. So J is going to be all tails. So it's just this event here, T and T, tails and tails. So when I'm answering this letter, this question E, I'm going to look at J and H. So again, H is the green case, and we only have two options for the green case, HH and HT. We only have one option for the pink case here, TT. So they don't share any space in common. So we could say, yes, these are mutually exclusive. And this is because they share no common outcomes. And that's it. We have answered all questions A through E.